What are generics in C#? As always, we're going to start with the definition, and after that I'm going to show you several code examples that demonstrate the use of generics in C#. And if you find any of my videos helpful, please hit the like button and also subscribe for more C# tutorials. Now let's start with the definition. Generics in C# are a powerful feature which allows you to define classes, interfaces, and methods with a placeholder for the type of data they store or use. How is this helpful? Well, it allows you to write a class or method which can work with any data type without losing the benefits of strong type checking.
Okay, if you don't know what generics are, you can take a look at the screen. I have several declarations for classes, methods, and interfaces, and these declarations showcase the syntax and structure for using generics in class, method, and interface declarations. And as you might have noticed, there is always a T key, T value, T item, and this basically stands for type, and it's the convention used when we're using generics, not only in C# but in any other programming language that uses generics. We're going to discuss this a little bit later, so let's move on to the first code example. Okay, let's take a look at the first code example. I have a method swap, which is a generic method, and it is used to swap the values of any type in C#. What you see in the angle brackets, the T is actually the type parameter, and it is a placeholder, which means that when we use the method, we can use any parameter type. We can use it with an integer, we can use it with a string, and we can also use it with a custom class. So let's see how the method works. Inside the main method, okay, let me comment this code. Inside the main method, we declare two integers, a, which is 10, and b, which is 20, and we print a and b before the swap, and then we call the swap method and we print their values again. So let's run the code and see the result. Okay, before the swap, we get a is equal to 10 and b is equal to 20, and after the swap, we see that a is now 20 and b is actually 10, and we can use the same method with a string. We have two strings, hello and world, and again we're going to print to the screen their values. We're going to call the swap method and we're going to print their values again. So let's run the code, and we're getting before the swap hello and y equals world, and after the swap we get world and then hello.
And on the screen now you can see the key points of the generics in C# and their type safety, reusability, performance, generic collections, type, inference, and variance. You can pause the screen, read about them, and I'm going to continue with the code examples.
Before we go any further, let's discuss the T type parameter. So why is it actually called T? Can it be any other letter? Can it be anything else? Well, the use of T is based on convention, and where actually T stands for type. And this is widely accepted practice not only in C# but in other programming languages which support generics. And instead of T, you can use pretty much anything else. Let's say we want to use A, and our method is still going to work. Or you can use, let's say, my type. And again, if we replace the T with my type, let's make this smaller so it fits the screen. Our method is still going to work, and we just need to replace the T everywhere else in the method. We can also create a method which uses more than one generic types. I have created a print types and values method which uses two generic types, T and A, and inside our method we simply print to the console the first parameter type and value, and then the second parameter type and value. And let's demonstrate the use of this method. I'm going to declare my integer, which is number equals 10, and then string, which is text, equals hello, and then we're going to call the method and pass the two parameters, number and text. So let's run the program and see the output, and we get the first parameter type is integer and value is 10, and the second parameter type is string and the value is hello. Okay, now let's go back to the example that we started with, and I'm going to demonstrate the use of the swap generic method with a custom class. So I'm going to delete this part of the code, and this is my custom class, which is called customer, with a single property name, and we also override the toString method to print. Actually, let's remove this one, and to print the name property of the customer class. So let's create two objects. We're going to call them customer 1 and customer 2, and let's call the first customer Bob and the second customer Janet, and we're going to make this object customer 2. Again, we're going to print to the screen customer 1 and customer 2. Okay, let me copy this. 2 and customer 2. So let's run the program. Up to here, we see customer 1 is Bob, customer 2 is Janet. And again, we're going to call the swap method. Let's do that quickly. We get customer 1 and we get customer 2. And again, we're going to print the customer 1 and customer 2 to screen, and let's run the program. And now we get customer 1 is Janet and customer 2 is Bob, which demonstrates that our generic method actually can work not only with doubles and strings, but also with custom classes such as the customer class that I have just created. Okay, so why do we use reference to T first and reference to T second instead of T first and T second? Let's see what the difference would be if we do that. Okay, I'm going to remove the reference, and right here we're going to use customer 1 and customer 2, and now if I run the code, let's see what happens. We're getting customer 1 Bob, customer 2 Janet, and even after calling the method, we get still customer 1 Bob and customer 2 Janet. Why is that? Well, in C# when you pass parameters to a method, they are passed by value by default. This means that the method receives a copy of each parameter, and if I modify the parameter inside the method, the change does not affect the original variable. And in order to actually modify the original variables, we need to use the ref keyword. Now let's take a look at another code example, which demonstrates how the generics enforce type safety. I have a generic class, which is called container, and the parameter of this class is T, which shows us that this is a generic class, and the T type is going to specify it when the container object is actually created. As you can see inside my main method, we create a container for int, and we can then create another container for string, and we also have a property with a getter and setter, and the type of this property is also a generic type parameter T, which also means that the value property can hold an object of any type depending on what type is specified for T when an instance of the container class is created. And we also have a constructor right here, which takes a parameter value of type T and assigns this value to the value property. And right here we have a generic method which is called print value. You can see that the method is generic since we have a T type parameter in the angle brackets. It also takes a container T parameter and simply prints the value in the container to the console. Now let's see how the type safety is enforced by the generics. When using generic methods, you can actually specify the type as I am doing right here. I first create a container integer class, and then I call the print value method, and I can specify the int, or I can actually let the compiler infer the type parameter. You can go either way. I'm just doing this. I'm specifying the parameter for clarity, and below that we create a container for string, object, and again we're calling the print value method with a string type parameter. So if I run my code up to here, it should be working just fine. And you see we have the value in the container. In the first container is 123, and the value in the second container is hello generics. Now if I take a look at this line of code right here, the one that is commented, this line actually demonstrates how generics enforce type safety. If I uncomment, if I remove the comments from this line of code and I specify the input parameter as int, but using the container with a type parameter string, that we are getting a compile time error which says we cannot convert string to int, and this is how the generics enforce type safety, meaning that if I want to use this generic method with a t type, I need to make sure that the t type for the container class is the same, meaning that if I use the int container, then all should be fine. Or if I want to use the instance of the container class with a string input parameter, then I need to specify string, and if we put the string container as the input parameter, then our print value method should be working just fine. And this is how the generics enforce type safety in C#. And C# also comes with a variety of generic collections which are found in the system collections generic namespace. I have listed some of them, but there are many more, but you should be familiar with at least some of them. The list and linked list, dictionary, sorted dictionary, queue stack, and hash set, you should be familiar with at least some of these. And also, if you have ever developed a threaded application, you might have seen or used the concurrent queue, concurrent stack, or concurrent bag. And if you want to use, let's say, the list collection, you can use it with integer, you can use it with string, you can use it with custom type objects as well, which is what the, let's make this one decimal, which is what the generics provide, which is the functionality of the generics. And if you want to take a look at some of these collections and familiarize yourself with them, you can go to the official documentation and learn more about these generic collections. And now let's take a look at the last code example for this video, which demonstrates how using generics could actually be counterproductive. So let's say you need a simple class, which I have called simple operations, with two methods that increment integers and doubles. You can either create your simple class operations and have two separate methods, increment with a int parameter and the increment with a double parameter, and each one of these methods increments the number by 1 and returns it. Or you can actually use generics. So let's comment this one and remove the comment lines from here. You can actually use generics with again, our class is going to be called simple operations with the generic increment method, but you can see that this is much more difficult to read. I also make some assumptions here that I should be able to convert the input type parameter to double, which might not be always the case. And if you're wondering what this part of the code is in C#, you can actually put some constraints to the t-type parameter, and right now we are specifying that our input t-type should be a value type and should implement the iConvertible interface. But again, this is much more difficult to read. It is difficult to maintain. So when you need only a handful of methods, such as the two increment methods that I need in my simple operations class, I would much rather create my two separate methods and leave it as is. And that is all for me for today. Thank you for watching.